started recording, then unmute.
So, good evening, friends. We were hoping to wait for some people to join, but I think it will be late. And for that reason, we are hoping to start with those available, then the others will join us. For those who will have missed, to go back and try to review with the YouTube recording that we shall have uploaded. For those who wanted recording for yesterday, unfortunately we didn't record, but we shall see. We shall make a recap. We shall try to give you a recap of what we went through. We discussed yesterday, and then you will be able to also catch up. We shall try to compile some things and then give you the feedback, and probably tomorrow what we discussed yesterday in digital circuits. And today we shall be focusing on Java, advanced project-oriented programming in Java. Remembering that we had finished the if-else, if ladder in our control structures. So today we want to resume from where we stopped, and we had stopped on if-else, if ladder, and we had completed it fully. So that means today we shall be focusing on the switch statement. The switch statement is an alternative to the if-else, if ladder. So they can give you the if-else, if ladder, then they tell you to convert it to the switch statement. Or they can give you the switch statement, they tell you to convert to the if-else, if ladder. So today we are just going to see how to use the switch statement, do an example, and we move on to loops, because we want to finish loops and enter into the object-oriented programming. As we shall be doing some past papers, we shall be able to do the questions related to the switch statement generally. But right now, we are going to focus on understanding. We are going to start on the Java switch statement, and we are saying, according to what you are seeing me display, here, that is the screen I'm sharing, the if-else, so the switch statement. And we are saying that the Java switch statement allows a variable to be tested for equality against all values. Yes, we are going to understand that. So each case, so here we look at every condition as a case. So each value is called a case. Each value we are trying to test for equality in comparison with our variable is called a switch. So it's called a case. And the variable being switched on, meaning the variable being tested right now or being checked for equality, is now the variable being switched on is checked for each case. So the switch statement can be used when multiple if-else statements are required. That's what we call the if-else, if ladder. Why did we say that it is called the if-else, if ladder? Because it keeps on repeating using the else if until all the conditions which we have referred to as the cases are done. So it can have multiple code blocks, and along with the case values, and executes one of many. Executes only a single code block based on the matches with the case values. What does that mean? We mean that because when you look at the syntax, that's the syntax for the switch statement. The syntax for the switch statement, that one. So what you see there, this is the general syntax, not the entire code, the full program where you have the public static void main. No, we are just looking at the general syntax of the switch statement. So the switch statement is written like this. You write switch, then inside here you provide the expression, sometimes also known as the value. The value. So the variable. Yeah. Okay. So some concern that will we be able to go through the test paper? Yes, of course we shall do the test paper, and that one will take us one session. Then we shall have 2 more sessions to do the exam for the previous year, because it's involving all the questions that are going to be set in this paper. We shall be doing the final exam, so we shall have time to do the test plus the time to do the exam. So right now, what you see here, these ones in gray, those ones you see in gray with double slashes behind them, those ones are called the comments. They just used to explain our code. They used to explain our code. So the compiler ignores them. Just assume they are not there. They're just there to help us explain the code. So here we are saying that the switch, here we write switch, open these brackets here. Then inside these brackets, you provide the variable. Inside these brackets, I think let me copy it and put it in our compiler. Then we can explain from there. People may get confused when I try to explain from here. Okay, so I'm copying it and pasting it here so that I can explain it more clearly when people are able to see everything. Switch. I think that's not even necessary. Okay, this is the general syntax. I'm removing all these comments so that they may not confuse people. I'm removing the comments to avoid the confusion. Yes. Maybe here. Okay, yeah. Let me just remove this. Avoid the confusion. Okay. So, people, I hope that one is clear. So, if we are all able to see that, we are saying that the switch, here you write the switch, then you open these brackets. Inside these brackets, you put the variable, like the variable you want to test for equality. We shall see an example and understand better. Here I provide what? The variable you want to test for equality. The variable that is having that value which you want to test for equality. And then we are saying you open the switch and then close it somewhere. You see it is opened here and then it is closed here. Then after that, here you come to provide the case. The word case, this one is a keyword. When I say keyword, that means it will never change. It will always be case. Yes. Then here you provide the value. You provide the value you want to test for equality. It may be a character, it may be an integer, it may be what? In other words, it must be an exact value. It can be a string, but it cannot be an expression. Like here, we cannot have x plus y as a value. No. It should be what? An exact value here. Then you provide these full colons. I think they are called the full colons. These ones. Like that, that's the syntax. The case is a keyword. Then here you provide the value you want to test whether it is equivalent to the one you have in the variable. So this variable is the one you are trying to check. Is it according to the value here? Then after you provide this full colon. Then down here, you can have some statements, or you may not even necessarily have some statements. Statements, I'm trying to mean that here you provide what you want to be done. That is if this value matches with the variable. If the value matches with the variable, that means this case is true. And then here, down here, you write whatever you feel like you want to do. And that's what I'll call the statements. Then you break. So break is also a keyword. Break and then you terminate. So break is a keyword. What do we mean? That break is a keyword. It's a value you can never change. Sorry for that distraction. We have been ambushed, but we shall continue. So we are saying that break is a keyword. And when we say keyword, it means that it cannot change. And what does the break keyword do? This is very important. I'm going to explain the break keyword. Someone can trick you and asks you the break keyword in two concepts. It can be used in two concepts. We can use the break keyword in two ways. We can use it in a switch, and we shall see how do we use it in a switch. And still, we can use it in loops. The break keyword can also be used in loops. And note down these things because they are very important. If they ask you in the two different cases, don't reply the same way. How do we use it in case we were using it in the switch? Let's start with the one where we are using it in loops. In loops, imagine, because we know that loops allow us to do something very many number of times until the condition that you have specified becomes false, then the loop stops. In other words, the loop is like something is going to keep on repeating itself until the condition you have provided for stopping is true, then the loop stops. But imagine when you want to stop even before the loop or the condition is true. There we use the break statement. So the break statement, when you are explaining it in the concept of loops, it is used to terminate a loop even when the condition for stopping is not yet true, is not yet achieved. That is the point. Then for the switch, it is different. That's why I want you to note it down. That for the loops, it is used to terminate loops even when the condition for stopping or for terminating is not yet true. Then the break statement, when it comes for the switch, so the break keyword, when we come to use it in the switch, we are going to see what it does. But first note down for this because we have not yet reached there. We have not yet reached for the loops. That's why I want to just give you the brief knowledge of how to use it. But for the switch, again, it is used when you want to show that to terminate a switch. It is also used to terminate a switch. That is if the case value matches a variable value. When you feel like this, you want only this to be executed. There you will have when you want to mean that when this value is equivalent to the value in the variable, please stop, only execute these ones and stop. There you use the break statement. But if you feel like even if this is true and this is true that it is equivalent to the variable, please continue. Then you will leave out the break. Meaning the break is optional. For this case, the break is what? It's optional. But it is you who will be able to know when do I need it. You only need it if you only want one case to be executed. Only a single case to be executed. For someone who wants this only the statements under this case, maybe I'm going to differentiate it and I say value 1, value 2. We can have as many cases as possible. So I'm going to just explain using those two values. Though we could even have another one here and we say case value 3, and then you space, then you use that here, whatever. Then we say statement C, and then we break. Then you break. So what are we meaning here? That for someone who wants only the first case to be executed, like you're meaning that only the statements under case 1 should be executed. That is if this value corresponds to be equivalent to the value in the variable. There you will provide the break. But for someone who feels like even if this is right, that the value 1 is equivalent to the value in the variable, still go on to even execute the statements in the case 2. There you ignore the break. You understand? That's why we say that the break is optional. It's only used when you feel like you want to use it. Then we shall see cases when you won't need to use the break. So what does that mean? That if the computer checks and the value 1 is equivalent to the value in the variable, only these statements will be executed and then the break statement will be will be detected. Once it is detected, the compiler will ignore, the computer will ignore the rest of the statements under the case, under the switch statement. Hope that one is clear. Once this value 1 does not match with the value in the variable being tested or being switched on, sometimes they say being switched on, then it will ignore whatever is under case 1, and then it moves to check for value under the case value 2. It will go on to check value 2. You see that every value we are testing for equality with the value in the variable is referred to as a case. That's what they meant. That each condition here is referred to as a case. A case when we have value 2. Does it match the value in the variable? If yes, then these statements will be executed. If we encounter a break, then it will ignore the rest. It will ignore those below that case, and still it will ignore those above that case. That's what they mean. Then from there, if this fails to be equal to the value in the variable, then they will ignore it as well and check for case 3. Not until we've realized that all the cases we have do not match, their values don't match with the value in the variable, then we shall have a case called the default case, and this one is also optional. Default is a keyword, and this keyword is still also used in very many ways. It is used in 2 ways. It is there is where we use it in a switch, then there is where we use it as an access modifier. For the access modifiers, I think I will explain them in a short time to come. But right now, let's understand the default keyword in the case of the switch, when we are working under the switch. So the default keyword is used when you want to mean that if all other first cases have not returned to be true or have not evaluated to match with the value in the variable, please always execute the statements under the default case. And don't say default case, just say default. Then you use these semicolons, these full colons. They are very important for every case, so don't ignore them. They are not for design. So you will find in some programs they are writing these statements just after in the same line with this. It is okay. Why are we writing it on a new line? To make our code readable and neat. Sometimes you can even find when all the statements are written in one line like this, like that. Then even the break is also on one line like this. Still, it will be okay that the statements are in one line, the break is also in one line. This one is also okay, only that it makes the code not readable and not neat. So that's why for us we go on to write each on a new line. But once you find they have done it like that, it's also okay. I give all the cases, the situation is such that if you read in the paper and you have seen they have written this in one line, don't say it is an error. Or don't be confused. So that's why we are saying that for the default case, or the case where we have default keyword, these statements under this case will only execute. That is if all the first values in the first cases have failed to be equal to the value in the variable. Hope that one is clear. So that is how the switch works. Then you close the switch. We shall always have only one case being executed unless you have not provided a break on that specific case. Like if we had left out the break on case 1 and we have deleted it, the computer will come and check. Even if the value 1 will match equality with the value in the variable, it will not stop. It will execute the things under the case 1, and then it goes on even to execute the statements under case 2, even if this value 2 does not match the value in the variable. But because there is no break telling the computer, please stop here, it will go on to execute even what is here, what is in this case value 2, until it experiences a break. Then it will stop. Even if there is no break still here, it will go on to execute all the nonsense. That means break is very important. Know where to use it and know where to leave it out. Even if they are saying that it is optional, but you have to know when it's optional. When are you able to leave it and when are you not able to leave it out? So that's all about the case, the switch. So we are just going to look at one example. We understand it, and then we move to the loops. We have to make sure today we finish loops, and then go on to look at the object-oriented programming. We look at classes and methods. the ones that where the lecturer last discussed, so that we can now people can do the other coursework or can understand the. Okay, we can now start. The moment we finish object-oriented programming, and that means the moment we finish classes and methods, next time we meet, we shall be doing the test. After the test, we shall now dive into the exam. We shall no longer have to focus on understanding, on the concept of understanding, because we shall have understood all the basics we need. We finish loops, we finish classes and methods. We shall then move to the test. After the test, then we shall move to the exam, and that one will be done in 3 sessions from now. 3 sessions of programming, we have to have achieved that. So we have to be a little bit quick in what we are doing. So that is the general structure for the switch, like how it works in general. That's why here they are telling you that you can have as many number of cases statements as possible. You may not necessarily have one statement like this, but many things can be done. You can even have another switch under one case, and a specific case. That's what we call the nested switch. Like a nested switch is just a switch within a switch. For you can choose that, hey, if this value is true, please consider another switch. Then you write another small switch under a given case. Hope that one is clear. That one is the nested switch. With time, we shall see, as we shall be doing the past paper for last year, we shall see all the tricks being examined. Because we have guaranteed that the moment you understand that paper, you'll be good to go. So I'm closing this. Let's go to look at an example. So here are some of the rules that apply for the switch, but we're not going to go through them because we have basically understood what a switch is. That the variable used in a switch can only be integers, convertible integers, that is byte, short, int, and cal. Those ones we saw. Strings and enums. We don't expect you to pass there an expression. Okay, you can pass there an expression as long as it carries that data type. So it cannot be void. That's what they are trying to mean. It cannot be void. Then they are saying that you can have any number of case statements within a switch. That one we have seen. So the value for the case must have the same type as the variable, like the value you are switching. Yes.
For me, where I'm confused, how can you use a string in such a scenario?
Okay, what they have meant here is that the value here, the variable, should have or should be storing a value of data type of a string. Like if you are checking maybe for a name, you can have already created your variable here, maybe saying string variable. You understand? Then maybe in the variable, maybe you are telling someone to enter their name. Then you store that name in the variable. Then after that, that means the name will technically the name will be the one here, that name. Then you will come here and provide the different names for the different students. Maybe you want to check which person has entered which name. If this name someone has entered here, which is the string now, matches with the name which is here, then we shall say that statements should be executed. You understand that? Yeah, that's what they mean. So here we are saying in the some of the rules that people will go there and read through, but almost I have explained everything, that the switch statement can have an optional default case. We are saying that the default case is optional, and usually you will find that the default case is used when all someone has entered something that does not match any of your cases, or when all the cases are not true. That means maybe you told someone to enter their age and they entered the name. That means that one is not going to match any of our cases. So by default, we shall maybe display something that maybe enter a valid name or enter a valid age. You understand? That's the default. So it is optional. You may not necessarily have a default case. Maybe for you are going to guide your users that enter your name, which is a string or which is a collection of characters, or you may be specific, or you may not even, it is not compulsory to cater for those who enter a wrong name. So that's why they are saying that default is optional. But I wanted you to understand that it can also be there, and usually don't have it accounts for some marks. So even if it is optional, I advise that if you have time, you are not rushing, include it where necessary. So that's why they say that not every case needs a break. We have understood when we need a break. If no break appears, we saw what happens. So when a break statement is reached, the switch terminates. That one we have seen. So meaning most of the rules have been saying them in the explanation. So if they tell you to draw a flow chart, so and when they tell you to draw a flow chart for the switch, it looks like this. I don't know if I have to go through it, but it can carry some marks. That is if they have asked. But it is easy. See here that you provide the expression which you have called our variable. It can also be an expression. After providing this, you go on to check for the first case. If the first case is true, the code block 1, which we have seen, those statements under that case 1 will be executed. If it's not true, then we shall check for case 2. Then if the case 2 is true, then we shall check for code block 2. That's under the case 2. Then like that, this one will show continuity. That we shall continue for as many cases as we may have. And then we shall consider our default case, which we are calling the code block n. We don't know what our default case will be, it will be which number of block which will be the default case. The default case is like always our last case, which is even option. Then after they are told here, this one is what you see here. These symbols. This one is the show joining of two conditions or two different statements. These ones they are showing you that here we can join the different cases. That's if we don't have a break. Then here you can see that they are joining to come to a stop. So that is all technical. So here is an example, but someone is saying that instead of taking an example that already, why did I have to want to take an example that already exists to save time? But we can choose to do from scratch. We do our own example based on the what? On an example, we can do an example for based on the exam that was done, right?
To write a program that prints out the day. If you enter number maybe 1, it prints out Monday.
Oh, okay. Someone is saying that we can do an example with the question this one. So let me write down the question, then we do that one from scratch. Someone is saying that write a program such that someone has a question already. Is it a test question? Okay, I think it is here. Write a Java program that reads a number from the user, which must be an integer between 1 and 7, and displays the name of the week. Displays the name of the weekday. Here you see that they are not specifying that we use a switch, but we can use a switch. Why? Because we can test for equality. Whenever you find you have a chance for test for equality, for the condition for you to achieve something, you use the switch. For example, you can test if what someone has entered equals 1, equals 2, equals 3. So you see that you have a chance to test for equality. That's why we shall use a switch. They will not necessarily tell you what to use, but you can have you can choose to find which one to use. You see that here we can use the if ladder, or you can use the switch. That's why I'm saying that they can give you a program written as a switch, then they tell you to convert it to an if else if ladder, or they can give you the if else if ladder, then they tell you to convert to the switch. So right now we are going to use a switch to answer the question that was done in a that was given to us in a test. That is part D, question 1, part D. Write a Java program. Okay, let me write it here briefly, very fast. Write a Java program, just in case someone doesn't have the paper we did. That is it. Write a Java program that reads a number from the user, which must be an integer. See that they are giving you almost everything between 1 and 7, and it displays the name of the day. So hope that one is seen. So that is our question. Then they are telling you that test data input number. Okay, there they are just telling you to like what your output should be looking like. The expected output. Like when someone here they are telling us that okay, there is something that is down here that you will always face in the paper. That someone says test data input number, then it provides a 3 there, and then it says expected output Wednesday. So what does that mean? Let you not be confused. This one is not part of our question. It's just a guideline to tell you that expected input number. They are trying to mean that you assume that if when someone enters a 3, we expect your program to be able to bring a Wednesday, just to guide you that how your output should look like, and then just to guide you on what each number is going to represent. Yeah. But that one is not necessarily the part of our question. It was just a guiding statement. So here we are saying that someone tells us to write a Java program that reads a number from the user. That means here we have to enter from the keyboard. Allow someone to enter from the keyboard, which must be an integer. They are even providing to the data type that our variable, which we are going to test for equality, should be an integer. They are provided the data type for that variable. Are we together? That it must be between 1 and 7. They are guiding you on which values someone should be allowed to enter. 1 and 7. And displays the name of the week day. Based on what someone will enter, we should be able to display which day corresponds to that number. Hope that one is clear. So let's start on our program. First of all, we say that the rules are first interpret the program, know the variables you're going to have, then you start. Right now, we already know everything. We know that we shall have a variable to store whatever number someone is going to enter, right, from the keyboard. Then, what else? I think that is all even. That is all. Then we shall be able to display what someone is going to enter. So, based on our switch structure, which we said the general structure for the switch. I don't know if I have deleted it. Yes, the general structure for the switch. The syntax. We saw that we have a variable here put here. So what is going to be in our bracket here? What will be our variable? Number that someone is going to enter. We shall choose. You can choose any name. You can choose to call it a day as your variable name. Or you can choose to call it number. Where you're going to store. Then you provide that day, that variable, which is going to store the number someone is going to enter here. After providing it there, here you provide the values. Which values? You provide the 1, 2, 3, 4, 5, 6, 7. Those are the values we are going to test for equality with the value someone is going to enter. Let's start on it. Here is our code, and I'm removing everything because we are going to be in the paper and we don't expect to have anything written there. So we are starting. How are we starting? We saw that we have to enter something from the keyboard. We are allowing the user to enter a number between 1 and 7. And for that reason, we shall, don't worry, this one is Oraimo. So for that reason, we shall be able to, we have to import something. We have to import the scanner class. And how do we do it? We said that we say import space using small letters. Import keyword is all entirely small letters. Then we import the library, which is Java library. Then dot, you dot it with the package which the scanner class, in which the scanner class is found, which we said is util. Import java.util, then dot. We are importing the scanner class, but we have the right to import everything, all classes under the scanner, so under the utility package. And that's why we are saying dot star. I'm no longer explaining that so much because we talked about it so many times. Import java.util, then dot star. That statement is going to allow us to import the scanner class. Yes, any question? Someone asking anything? Okay, so let's continue. We are saying we have imported our scanner. Now the next thing is to write our class, which is going to be public class switch demo. I've just chosen my class name to be switch demo because I'm not limited in the question on which class to use. Then I open my class from here. Is someone trying to ask anything? Okay, so we are saying we have created our class, which is now public class switch demo. Switch demo is the name of our class. Then the next thing is to what? What's the next thing? Next thing is to create our variable, right? But we can't create the variable under the class, but we are going to do it under the main class by saying public static void main string arguments, which we are calling args. Then open and close the switch. So the what? Open and close the square brackets. Then we open our main method. Open our main method. Then the next thing is now to create the variable, which is going to store the number someone is going to what? Enter from the keyboard. Which they have told us that it should be of data type integer. The question says that. Then that's why I'm saying that int, I can choose my name of the variable to be day. You can also choose yours to be number. You can choose anything as long as it carries some meaning. Yeah? Then I terminate. I'm not storing there anything because I want to allow someone to enter from the keyboard the value. And to enter from the keyboard, we use the scanner class. And the only way to use the scanner, we use the methods under the scanner class. But the only way to use the methods under the scanner class is by creating an object under the scanner class. How do we create an object under the scanner class? We do that under the main method by saying provide the name of the class, which is now scanner. Provide the object you want to use for the scanner. You can use obj equals z. Then you provide the new keyword, which is also standard, you cannot change. Then you provide the name again by saying scanner. Then you open the brackets. Inside the scanner, you put the input stream object, which is said system. This one is called the input stream, which you say system capital S dot in. Then you close and then you terminate. There you have created an object obj for the scanner class. So through this object obj, we are going to be using the methods under the scanner class to allow someone to enter from the keyboard. How are we going to do this? Because we are entering an integer, and we know that whenever the methods under the scanner class, we have next, which allows us to enter a bit of a stream of characters, which we are calling a string. It can also allow it to enter a single character. But we don't want to enter character. We want to enter whatever we are entering as an integer. So we have to modify next to become next int. If we wanted to enter a double, it would be next double. A float, next float. Right now we are entering a what? So how do we use the object to access the variable? How do we use the object? How do we use the object to use the method, to access the methods under the scanner class? We shall say object, which is now obj, dot the method we want to use, which is now next int. Next int. And then you open these brackets and close them, and then you will terminate. So what we have done is that we have used the method, and we are allowing someone to enter something, right? But we are not storing whatever is entering anywhere, right? So we have to allow someone, we have to store it somewhere by assigning all this to the variable day. By assigning all of this to the variable day. So we shall say day equals, are you seeing? I'm storing whatever someone is going to enter using this method into the variable which you created, which was day. But are you seeing that this person is going to be able to enter, but it will not have any guidance on what is entering? So meaning on top, before writing that method, we had to write a guiding statement which says maybe enter a number, maybe enter a number of the day, maybe between 1 and 7. You can choose any guiding statement of your own choice. So me, I'm choosing to say system, and how do we provide a guiding statement? By using print statements. System.out.println. Then inside here I will say enter the number of the day. Then I can even go on to guide this person in brackets, and I say 1 between, I can even not just say between 1 and 7, and then I close this double quotes, I close the brackets and then terminate, so that someone now knows what he's trying to enter. You see that I have provided a guiding statement that says enter a number of the day between 1 and 7, right? Meaning someone will now know what he's trying to, the program is requesting him to enter. And I'm saying it is not this statement that is allowing the person to enter something from the keyboard. No, this is just a guiding statement. What actually allows the person to enter from the keyboard is this code line here, line 9. Hope that one is clear. So the next thing is now to write our switch, because now we have gotten the number someone is going to enter. Now we have to go on to test it for equality with our numbers that we have on the list. Our numbers we have on the list that we want to test for equality are also 1, 2, 3, 4, 5 up to 7. So we are saying you write your switch. Then inside here we said inside the switch we provide the variable which we are testing for equality. The variable we are testing for equality is the value someone is going to enter, which is now day. So here we say day. Sorry, inside there we provide day. So from there we open our switch. We have provided a variable inside the what? The switch, which we are now. This one is what we call the variable that is switched on. Why do we say it's switched on? It's the one we are testing for equality for the different cases, right? And it can also be an expression. Some people call it an expression, but it is a variable right now according to what we are doing. And I don't want to close my switch statement because I'm in the paper. I'm writing as if I'm in the paper. So we continue. Next thing is now starting to write our cases. Case 1, which we are going to say case. I think case is a keyword. That's why you see even my compiler suggests it just below there. So you say case. What are we testing first? We are starting from 1. You can start with anything, no problem. You can start to test with 3, 5, but it will just make your code disorganized. Though it will do whatever it's supposed to do. So case 1. I'm not necessarily mean that this is case 1, but the value we are testing for equality is 1. We are testing is whatever someone has entered, like a 1 is whatever someone has entered equivalent to 1. And here we have to put those full colon. You can choose to create a space there, or even if you don't put it, it's okay. Then below here, you provide what you want your program to do. That is if that value matches with the value that someone has entered in a day. What do we want to show here? They told us that we should be able to print the day of the week that corresponds to 1. And this one is now Monday. So how do we display? By using the print statement. System.out.println. Then inside here we print our day, and it is a string. So what day? Monday. We are just printing Monday because the output was requiring us just to print that day, not things like you have entered 1 and so the day is Monday. No, the guiding statement was that the expected output is just Wednesday, meaning just that day. That's why you see that in my print statement I'm just putting there Monday, right? Then I close and then terminate. Then the next thing, do we want only this case to be executed, that is if it matches with the value, or we want even other cases to be executed even if this one is true, even if only this one is true. No, what we want is that we want to display only a single day. That is if someone has entered a single digit, because we expect someone to enter a single digit. So that means here we have to break. Are we together? Here we are breaking. Why? We want to check if someone has entered a 1. Does that 1 match with the value that, okay, if someone has entered something like a 5, does that 5 match with the number that we have written here? If no, then this will be ignored. If he has entered the 1 here and then now we have 1, then we check, is it equivalent to 1 we have here? Yes, then we shall print this, and then we shall experience a break, and then we shall jump out of the switch. The rest will be ignored. Everything under that switch will be ignored. Hope that one is clear. Let's write our next case very fast now. Case. Now now we are checking for a 2. If someone has entered a 2, what should we print? Still we shall say Control C system. Below here we shall say, then that is a Tuesday, right? That is a Tuesday. Here we are doing it fast because we are doing the same things. Case 3. Case when someone has entered the what? Sorry, I've not broken. Which break? Yeah, we have to break, because we have seen that break is now necessary here. Break, terminate. Case, you can even choose to skip lines. It is okay. We said the white spaces are ignored in Java. White spaces we mean in new lines, space, and then tab. Case 3. This is now a Wednesday. Wednesday. Then break. Break. We try to minimize so that at least the code tries to fit there. Then next thing is case when we are checking for a 4. That will be a Thursday. Thursday. And then the next thing is now breaking. Terminate. Don't forget where I'm putting the terminating. Someone will come and terminate the case. Don't terminate the case. The case there we have a full colon. We are not terminating the statements and then the break, because break is also statement. Have I minimized too much? Okay, and then the next thing is now we are case checking when it's for the 5. Terminate. Provide that print. That will be a Friday. Of course, the numbers match with the day according to the guidance. Then break. Don't forget a break when you need it. There will be trouble. The next thing is case when we are checking for a 6. Then that will be a Saturday. Then again we need to break. Terminate. Case when we are checking for a 7, which is our last case. 7. And then that will be a what? A Sunday. The next thing is to break. And then we terminate. See, here I can choose to close my switch. I've closed the switch here, right? I'm closing my switch, which I opened on line 11, and now I want to close the main method. Don't forget to close the main number. The number of times are the number you open and the number of times you should close. Then next is I'm closing for the class. See, my program is complete. Someone is asking, where is the default? We said the default is optional. Why right now I'm not putting there the default? I was very clear. I guided my user to enter between 1 and 7. Any user who enters his name is a fool. Any user who enters a letter like M of 17 or 19 will be wasting his time, right? Though I can go on still to provide the default, and I say maybe enter an appropriate number, the default case, and the default case is also a case on its own. You just say default, still you have to provide those full colon. Then here maybe you say system, you provide a guiding statement telling this person please enter something appropriate. You can even say put there anything.
Is out of the switch.
Hey, it's out of the switch, sorry. Yes, that's right. It should be inside the switch, sorry. It should be inside the switch, sorry. It should be here. And then don't make a mistake to open a case. Like in the case you come and open curly brackets for each case. Don't do that. We have not done that. Even if you have 100 statements there, they will be considered for that case. As long as you are broken. So default, then we are saying system dot out. Then if you write the case outside the switch, it will just automatically bring an error, like you have seen what I had done. Then here we are saying maybe enter a correct number. Enter a number between 1 and what? And 7. Just maybe someone out of the blue enters a 9. Enters a 9 or a 10, where we guided them. So then we terminate here. So let's run our program because we are done. That's all we needed, right? We run our program and we shall see that they are telling us to enter a number of the day between 1 and 7. If we enter 6, if we enter what? A 6 and then press enter, you see that they are displaying Saturday here. Let's run a program again and maybe we enter 1. We expect a what? A Monday. Hope you can say Monday there. Now what about someone who is maybe a drunkard and he enters a 10? He has entered even 60, maybe 10. See, enter a number between 1 and 7. It goes on to tell the person to enter an appropriate, a correct number. Hope that one is clear. You see that the default case is only executed if someone has entered. Okay, it's only executed if all other cases have not been matching with the test value. Our test value is the day now. And if someone enters anything that does not match our cases, we shall now execute our default case. Meaning this one will only execute only and only when the cases have not passed the test. Hope our switch is now clear. We have properly understood the case. Okay, maybe one thing I can show you is that when I remove the break on case 1 and I enter a 1 which matches only for the case 1, what will happen? I'm removing the break on case 1 and I want to run my program. I put 1 which we expect to bring only Monday. What will happen? The program will run fine because we said the break is optional, but we will see how does it affect our program. I'm entering a 1 which we expect to be Monday. Let me even divide this. You see when I enter, they display Monday and Tuesday. Until the break is executed, is obtained again. What does that mean? That it will come and check. Yes, we have experienced the 1 which matches with the one someone has entered in the day. Then they will print that. Is there a break? No. Then they go on to execute whatever is down, even if it is not true. Even if someone has not entered a 2, still they will execute this until the break is experienced, then it will stop. Again, if I remove this break, they will go on to print 3 days. Hope that one is clear. Yeah. So that one is someone will ask, when do we leave out now the break? Okay, we have seen its effect, but when do we experience such a case? That one, you will go and read for me this example under this one, because we have this link. You see this example where they are telling you to, this is an example that he was working on a grading system, where someone who has gotten an A gets the same comment as someone who has gotten, someone who has gotten a B gets the same comment as someone who has gotten a C. So for that case, we shall not break. We shall just make sure that we provide the case B and case C, then we only break at C. Then we shall provide the same statement that tries to give them a comment. Hope that one is clear. I'm trying to show you all the cases, so you will not make a mistake in the paper. You just progress. So that example there, you can just go and you see it under the switch till it's there, you can understand it further. But that's all with the case. So the switch. That's all with the switch. Next thing is now we are moving to loops. Control structures, but based on loops. We have to make sure we finish this today. Otherwise, if we don't, we shall be moving at a very slow pace. And yet we have a lot to cover. So that is all with the switch. Control structures. Okay, here. Loop control. Loop control. We are done with the decision making. Now we are moving to loop control. How are we controlling the program that keeps on repeating? Yes. We are saying that the loop statement allows us to execute a statement or a group of statements multiple number of times, and following the general, and the following is the general loop statement in form of a flow chart here. Why am I showing you these flow charts? They are not emphasizing them, but you have to know that they are part of our course outline and they are highly examinable when it comes to designing tools. In lecture 1, we have design tools where we have algorithms and flow charts. Sometimes algorithms are also called pseudocodes. Right now, this is a flow chart, which is a design tool, trying to show you how generally a loop works. That you provide the condition. This is like the condition, because even if something keeps on repeating, there is a situation when it will stop. Yes, you see, when the world has to end someday, even if it is rotating, it will stop someday. Meaning there is that situation where it has to stop. So that is like the condition for stopping. Once this condition is still true, the conditional code will be executed. Once it is false, the conditional code for false will be executed. Okay, don't focus so much on that. Let's just dive into the different loops we have. We have these loops: while loop, for loop, do while loop, and then we have the enhanced for loop. That one we shall understand. But let's understand the first three. These are the most important ones: while loop, for loop, and then do while loop. Starting with the while loop, they are telling us that it repeats a statement or a group of statements while a given condition is true. It tests for the condition before executing the loop body. Don't worry, we are going to understand that. Let's just dive into the while loop. You see that I can tap on the while loop and then I can get the general information about the while loop. Still under that link. That's how important that link is, if you can access it. So here they are telling us that the Java while loop in Java it keeps executing executes something repeatedly as long as the given condition is still true. This is like saying, while you are still a kid, you keep on growing. Oh, while you're still alive, you keep learning. Like kusoma tekukoma. That's what the Baganda say, that learning doesn't end. Meaning if you're still alive, you keep learning everything, something new every day. Not until you die. So the stopping condition is death. When you die, you will not learn anything again. You stop eating when you die. So that's why we are saying that a while loop will be like, while this is still true, do this. You understand? While this is still right, do this. Not until that while, what condition you have provided in the while is false, then something will keep on executing. Hope that one is clear. Let's see. Let's move in the general syntax. The general syntax. Because when we understand the general syntax, everything becomes smooth. That's where we shall even see the break for loops. Okay, that's the general syntax. Very smooth, very simple. We are even going to take only 5 minutes on it. This is the general syntax. That you say while is a keyword, you cannot change it. Small letters, only small letters. So while, then inside here you provide the Boolean expression. Boolean expressions, greater than, less than, equal to, those things. So here inside here we provide our condition. In other words, call it a Boolean expression, or it can be any condition. But right now we are looking at it as an expression. Then inside here, after, if this condition is true, then here you will provide what you want to execute until when that condition is true. Are we together? Then there is one other thing that is always maybe sometimes written here. You'll find that maybe counter plus and you terminate. I'm going to explain that one. This one is not part of our general syntax. It may not necessarily be there, but in most cases it's going to be there. We are going to understand what it does. It won't necessarily be called a counter. But you see, when you are moving to the next, when you are growing, something keeps on increasing. That determines that you are that we base on to say that someone is growing. When as you continue to live repeatedly on earth, you are increasing your age. Starting from age 1, 2, 3, 4, 5, there is a criteria on which the age is incrementing. We start with your age counter as 0, plus 1, plus 1, plus 1 until you get to 90. So that's why I'm saying counter plus plus. This means that we are going to keep on incrementing. This one is called incrementing, or increasing something. We are going to keep on increasing your age by 1, 1, 1, 1, 1, 1 until you reach the age when you will die. That one is clear. So the same thing here, when you are moving on stairs. You start from the first stair, which is stair 0. Then you move to the next stair. You can choose to skip two stairs. That means that here we shall not have plus plus. We shall have to say plus 2. Meaning you are increasing your stairs by 2, 2, 2, 2. That's like the criteria for repeating your stairs. Hope that one is clear. That's just an example. This one can help you to. It is the one that is going to make this expression reach an extent when it is not true. Are we together? Like maybe here, if we are saying that while A is less than B, maybe do something. That's what we call statements. Then we shall come here and say A plus 2. That means they are going to come and be on increasing it 2 until this 2 is greater than B. Then the condition now ceases to be true. Yes?
Put it outside the curly brackets.
Yes, outside the curly brackets. Hey, you mean, okay, this one? Okay, some confusion. Thanks for that question. I don't remember very well, but usually it might be inside here. It is inside here. But if we put it inside here, no. It's okay. It should be outside. But whether it will be outside or inside, we are going to practice. And those questions can be proven by the compiler. Good enough we have the compiler with us. Are we together? So let's just dive into an example. To save time, let's dive into an example. So this is just a flow chart for the while loop. This is just a flow chart that we provide the condition. Once the condition is true, like condition, if the condition is true, code block, like the code under that condition, which we have seen the statements, which we have called our statements, will be executed. That's what they mean, code block. If the condition is false, then we shall jump out of the loop. So the loop is this rotation you see here. You see that it's only keeping on going there if a condition is true. Once it is false, we shall not go in this rotation. We shall just jump out of the loop and go outside, and then we come to a stop. Are we seeing? That's what they mean. That after we are maybe if we find ourselves moving down, we experience a while loop, we shall provide the condition for stopping. Once the condition is still true, we shall keep on moving in that rotation, that repetition. That's why you see that if condition is true. If it is not true, then we shall just jump out of that loop and we come to a stop. Hope that one is clear. That's basically what the flowchart looks like. If they tell you to draw a flowchart for a while loop, or they can even give you a program that contains the while loop, then they tell you to draw a flowchart for it. You will just based on the general flowchart, then you can stop what your modifications. Hope that one is clear. Yes, examples of the while loop. This is one. Are we understanding those in the online platform? You can unmute and tell me if we are together, or I'm rushing, or I'm alone. Yes, are we together?
Yeah, somehow following.
Good.
Somehow they are not.
But I want you to fully how be online, be together. Okay, let's first read through our example. This is the example. That in this example, we are showing, example is printing numbers in a range using a loop. So for this case, we are going to be showing the use of the while loop by printing numbers starting from 10 to 19. We are printing numbers from 10 to 19. Here we have initialized, okay. Our question is that print numbers from 10 to 19 using the while loop. That's the question. We are printing numbers from 10 to 19 using, or we can say, yes, from 10 to 19, or we can say, let's print the first 10 numbers using the while loop. Are we together? So let's dive into the code. The coding. So for those who have remembering, those who are remembering our question, the question says, print all numbers between 10 to 19 using a while loop. Now, do we need any? Do we need to enter from the keyboard? No. We don't need to enter from the keyboard.
Why?
Because they have told you just to print the numbers between 10 to 19, not to enter them from the keyboard, but just print them. Are we together? So, meaning all we need is to get a variable which is going to store our numbers, right? So after that, okay. So after that, all we shall need is to, we have said that we shall need a variable which is going to store the numbers. Okay, let's start. Let's just dive into the code. File, new file, Java file. Then we are looking at, right now we are looking at the while, so I'm going to call it while. That's just my class name, while demo. And then I'm removing everything. We are starting our program with say public class demo. I'm not importing anything because I'm not going to enter anything from the keyboard. So I'll just say public class while demo. I'm choosing my class to be while demo. Then I open my class. Then here I will say public static void main. I'm opening my main class. Public static void main string arguments. String arguments. Then I open my my main method. Inside my main method is where I want to write my for loop. Now, one thing I didn't talk about is that if we are writing our, we need to provide our starting point. Where are we? Because it depends on what you are really trying to do. But right now we are printing a sequence of numbers. But we have to provide where do we want to start from the printing. We want to start from 10. They have said, you have to understand the question. They have said from 10 to 19 is different from between 10 and 19. So always when they give you such questions, the understanding of the question is very key. You start from 10 when they have told you to between 10 to 19 to be wrong. So here we are saying from 10 to 19. Will 19 be inclusive? Because if you include something that is not inclusive, you will have written a wrong for loop that they have told you. So meaning, let's first create a variable. It's going to be an integer because we are working with integers, right? So int, we can say I. We can say just I. You can choose anything. Okay, let's say maybe, we can say counter. We can just call it anything. You can choose your own variable name. I'm choosing counter, right? Okay, let's just use a letter, maybe I, right? Int I. And we want to start when I is 10, right? So we shall say int I equals 10. Are we together? Now this is like our starting point. We have to provide the initial point, our starting point. Then we write our while and say while what is what? What condition? How are you going to write your condition? From 10 to 19. What is going to be our Boolean expression? You are mathematicians. While I is what? Because now our condition is based on I, on the 10. Because we are going to be printing I, the value of I is going to keep on increasing until we reach 19. While I is still what? While I is still less or equal to 19, When we say 19, that means we want to include 19 as well. If we didn't want to include 19, we should have said while I is still less than 19. Meaning, until this condition is false, then it will stop. Are we together? You have to be careful. Then you close that one, and then you open the block for the while. What you want to do under the while. So we want to say system. We want to print I. We want to keep on printing I. System dot out dot print ln. Then we want to print I. And then we terminate. See, it depends. They will guide you on how the output will be. That is, if they have guided you, they can tell you maybe they want them in one line, or if they can tell you they want them each on a new line. It depends on what they will have guided. If they want each on a new line, we shall see. We are going to modify our print statement. Then let's close our while loop. Then we close. Don't rush writing, because I'm going to introduce something there. I want us to first understand some concept. I'm closing the while loop, then I'm closing the main method, then I'm closing the class. Don't forget the number of times you open and the number of times you should close. So let's run our program and we see whether it does what we are intending it to do. See, it is printing just 10. It is printing 10 very many number of times until the program does not end. It is continuously printing. Why? Let me explain that. That's why I told you not to write, because I want to explain something after you have visualized what I'm trying to explain. See here, we are saying that until I is less than 19. But whatever we have written, there is no modification that is going to make I less than or to make this condition be false. What do I mean? I is going to remain 10 for the many number of times the program is going to run. Until we have written a code to modify I. That is what we call the increment and decrement operators. Let's first understand them. All those things they are not going to teach you, but they are going to ask them. Yes, they teach substandard, they examine standard, because we have ChatGPT, which can allow you to set questions as well, not only to get answers. You thought ChatGPT only helps you to get answers, it can also help you get questions to set for students. So that, okay, this one, they look like that. Those are the two operators that we are going to use here, make use of. These ones, they are called increment operators. Increment, it comes from the word increase. Increment operator. This one is, it's one operator by the way, not operators. Then this one is called decrement operator, from the word decrease. Operator. Someone will ask, but those things you are teaching us, they are not there anywhere in the notes. Wait, they will be there in the paper. And you will not know that they are there because you did not see them even in the notes. Something you have not seen in the notes. What is funny with the programming? You won't know that it is not there in the notes because you did not even see it. So you won't know that you need it. So these ones are increment and decrement operators. We use them in loops usually, mostly. But we can even use them somewhere else. These ones, they keep on increasing the value in the variable by 1. For example, if I have A equals 9, if I say A plus plus, it will mean that increase whatever is in A by 1. Now that means on a new line, if I print A, it will be 10. A will be containing 10. Are we together? Yeah. So when I say A is equal to 9 here, and then after I go down and say A minus minus, I'll be meaning that now decrease A by 1. So that means it will be A will now be containing 8 on a new line if I print it. Are we together? So the same thing. Someone can say, I don't want to use that one, can confuse. It is okay to say A plus 1, but it looks immature. That's why we used A plus plus for serious programmers. Those who are serious, yes. So, What if when you want to increase it by 2, that's when you can't say a plus plus and then you provide the plus twice. Maybe you say a plus 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 because you want to increase it by 2. No, that one is not allowed. Maybe you can just say a plus 2 or 3. Those ones that are not standard additions. Yeah, let's go back. That's all I wanted you to first put in head. So we are going to do the same thing here. What is the criteria that we are going to keep on adding, increasing? Because we want to print 10, 11, 12, 13, up to 19. We have to increase our I, to modify our I by 1. Meaning, we shall come and write. Now we want to answer the question where someone asked, are we writing that increment inside the while loop? When we say inside the while loop, we mean between 7 and 10. Like within these brackets, these ones. Are we writing within these brackets or outside them? Let's prove that by the compiler because I've also taken long without practicing. So let's prove it together. I plus plus, then you terminate. Sorry, you terminate, right? Let's run our program and see what we are obtaining. You see, it has worked. Right? Are we together there? Why we can't write it outside the while loop? Because when you write it outside the while loop, we have gone out of the loop. It is even out of its concern. What do I mean? That when I get this I plus plus and I remove it there and I put it here, I don't know what I said is whether whatever I said is right, but let's try to check and we see what happens. You see? It doesn't work. It keeps on running. And if you leave this program running and it's a very heavy program, it can make your computer crash. Only that this one is a light program. It cannot crash such an expensive machine. And 12th generation. 12th generation. So you run it on your 2nd generation machine, you'll have issues. Yes, you'll have issues. So we are saying, that was by the way, that whenever you are running your program, that's how we use the while loop, by the way. Hope that people have understood this program we have just written. Simple program, just to explain to us how to use the while loop. We are saying that here you provide the while. You provide the while, then here you provide the condition. Yes, the condition. That while this condition is still true, please continuously print this, then increase I. So let's first understand. Here we have provided the condition. So the computer will come and check the condition. Okay, the condition will be checked first. This is very important. The condition will be checked first. If the condition is true, they will do whatever you wanted the program to do inside this while loop. Then you see that it will experience an increment. They will increase I by 1. Then you go back and check again. Now I will be 11. Is 11 still less than 19? Yes. Then they will print. They will print that 11. So they will come and increase 11. It becomes 12. Come and check again. Is 12 still less than 19? Yes. Then you come and check. Then print that 12, then like that. Are we together? Hope we are understanding. Yes, you see that they are starting from 10 because we wanted to check, to start with the 10. So they will come and check, is 10 less than or equal to 19? Yes. They will print that 10. That's why we are saying that print I. Then they will increase that 10 by 1. So it becomes 11. Is 11 still less than or equal to 19? Yes. Then they print that 11. Then they go and increase it. It becomes 12 until now we are on 18. Then they will check, is 18 less than or equal to 19? Yes. Then they print 18. So they increase the 18, it becomes 19. Check again until now they reach 20. So if they reach 20, they will come and check, is 20 still less than or equal to 19? No. So it will just jump out of the loop. Just like that. That's all with the while loop.
Okay.
Yes.
But if I change and I begin with if I is equal or less to 19, still what?
We are now looking at loops. Those ones are called decision making structures.
No, what I mean. In your while bracket, when I change the order, the both sides,
And it say equals.
First,
That one is not allowed. This one is also an operator. Standard. That's how it is written.
okay.
That is an operator. Those we shall see different operators. Okay, if you get time, go to that link and look at operators. They are very important, and we may not get time to look at them. This one is called less equal or less than. Sorry, less or equal to operator. It's written like that. Don't write equals then less. It's not allowed. Then one other mistake that people usually make is, okay, this one is also allowed. What about when for you want to start by incrementing first, then you print? That one is also okay. But it depends on how you want your output to look like. Like someone can say, I'm going to first increment, then I print. Are we together? You can first increment, then you print. Increment, check, print. Increment, print, check. You can increment, print, check. Increment, print, check. Or you can check, print, increment, based on how your output, how you want your output to look like. Let's run the program and see what have we changed. Are we seeing that now we are starting from 11 and ending on 20? Are you seeing how the change has come? So they can write for you those two programs and they tell you to write the output. You write the two outputs. Just to test your understanding of the while loop. But this one is also easy to visualize. Come, see, we have I equals 10, right? Is 10 less than 19? Yes. What do you experience first here? Increasing. So it becomes what? 11. So that's then you print it. I think how 11 comes. So it is easy to analyze. And it is printing at 20. Because we have changed, it is increasing first.
It takes the printout.
Yes.
Maybe another question we are told just to explain us no line and the same line.
Okay. Are you saying that we have ln here? If you had print, not print ln, if you had print just, it will bring everything on one line. Are you saying? But not even without even space. Are you saying? You can choose to write to create the space there manually by saying that I want to print the space here. So I'll just say Ctrl C, Ctrl V. Then here I'll just leave this one. I'll print out. Or you can even use one print statement to print that space. I'll just come here and I use a concatenator. Okay. I'll just come and I use a concatenator and I print that space here like that. I see. I'm using a concatenator to print the space as a string. The space between those two letters, numbers. Let me run the program again and we'll see. Are you seeing? Are you seeing? One line, but with spacing. The spacing, I've printed it as a string as well. In my print statement here. Hope it's clear right now. Someone wants to know, what is the importance of this escape code /n? That is one is equivalent to a new line. This is when you want to print a new line. Still, it is a character. We can print it as a character, still as a string. We shall see when to use it and how to use it. So that is it with the while loop. We are not ending today unless we have finished all the loops. We are so sorry, but we need to save time. So that is it. So we have written and we have understood how the while loop works. Okay. Let's move to the next control structure. That is the for loop. The for loop. That is our for loop. Let's understand it as well. So the for loop is also a repetition control structure that allows you to efficiently write a loop that needs to be executed a specific number of times. So let's just dive into the syntax directly, then we will explain the general syntax. So the general syntax of the for loop is also like this. That is the general syntax of the for loop. Like it says that you write for, after writing for, you open, inside here you provide the initial condition like we provided in the while loop. But also it can also be out on top. Then after you terminate, then you provide your condition, which they are calling the Boolean expression. Then you update. This update is like a decrement or increment. Update your variable, like increment or decrement. The update can be increment or decrement. Are we together? You have seen why we can even need to decrement. Like if we wanted to print reverse, They can give you the numbers, then they tell you to print them reverse, starting from 19 back to 10. There we'll use decrement, but you'll change your starting point. Maybe for this case, you would start from I equals 19. Then even your condition will change. But you just have to reason mathematically and logically. Then you'll achieve that. So, here they are telling us that for then initialization, like your starting point, give your initial point of starting. Then you see that these three are separated by a termination, not a comma. I usually make that mistake, but I beg you don't. Don't terminate, don't use a comma here, but a termination. Very, very important. Then inside here we provide our statements. That is if this condition is still true, or this expression is still true. This one. Then here we provide what we want to do. Let's go to an example. Okay, maybe the other thing we have to look at there is that here we don't check. Okay, here we come. Okay, let me first dive. Initialization, a Boolean expression, then a body. Those ones we have seen, like the statements. Here is the flow chart. Initialization. You initialize first, you give a starting point, then you provide the condition. Then if the condition is true, we shall execute the code, then increment or decrement. Then you move in that loop like that. Not until the condition is false, then we shall just jump out of the loop and stop. That is the flow chart. Then Java for loop. Example. Let's look at an example. We are saying we are printing number in the range. Okay. Maybe we can still work with the same example to see how we can achieve the same thing. Because all loops can do whatever the other does. Each loop can do what the other loop does. So let's achieve what we have just done, but this time using the for loop. Just gonna, should we just modify our program or we write a new program? Okay, to save time, we are just going to modify this program of ours. So I'm just going to remove the while loop like that. I can even choose to remove this. Based on our general structure, we said that you write for loop for. Then inside here we provide our initial point, which is now int I equals. That's where we are providing our starting point, which we are calling the initial point. We want to start from 10. We said we terminate. We separate it with termination. Then we provide our condition. The condition is I being less or equal to 19, because we are printing between 10 to 19, or from 10 to 19. I being less or equal to 19. Then again separate with a termination. Then we provide our increment or decrement operator. What do we want? We want to keep on moving up, forward. That means we have to add. So you can say I plus plus. But even for someone who will have said I plus 1, it is okay. It is also okay. Then you close the bracket, then open your for loop. Then inside the for loop, what do you want to do? Maybe you want to print the I now. System. You want to print I dot out dot print ln. Then here we are printing I just. Like we may not necessarily be printing ranges in numbers, but just these are just the basic examples to help us understand the functionality of the for loop. So when we run this program, because it's now done, you see, it is giving us the same thing given the other was doing. Simple.
Basically, what is
the difference is the syntax. Just the syntax. That here everything is provided inside the bracket. These opening and closing brackets inside here. The braces. What they are brackets? What braces? But which is not the case with the while loop. You saw how the while loop was looking like. The syntax is what is important. And even the order. That for the while loop, we saw that you first check the condition. Then you do something. But you look at this. This one, you provide the initial condition still. Check the condition. Don't increment. But look here. That here you provide our starting point. That's what is important here is looking at how the loop flows. Here we provide our starting point. We check the condition. Of course, for all of them we shall provide the starting point, but we check the condition. Don't increment. You may assume now you increment. No. After you have checked the condition and the condition is still true, then you just jump, you come here in the body. You come in the body and do whatever the body wants to do. Then now you can't increment. You see the difference? That however much you are seeing the increment here, you don't look at it first. You first check, you just go check the condition, come in the body. If the condition is to come and in the body and do whatever you want to do. Then you increment or decrement, then you come and check the body. So you check the condition again.
That's why you terminate.
Yes, that's why you terminate. This termination means these are just the statements. But however much they are written in one bracket. Are we together? That initial condition is provided, right? Well and good. That's why I'm saying that you can choose, you can have this one written outside here. It is still fine. You will find in some cases they are writing it here. Are we together? But if they write it there, why is it bringing an error? Okay. Okay, I'm going to explain it. Okay. I'm going to explain that, don't worry, because it's also possible. Like you can choose to first declare your variable and don't give it a value. Then you come and use it here still as an initial point. Like the initial point will always be in the bracket, but you can create the value that is storing it outside. Are we together? Here we are creating the variable, but we are not giving it a value. Then here we are using it to store our initial point. Though we can still declare an initial as still inside. That's what I was trying to show you. Yeah. Then you can check the condition. Don't increment first. Go in the body. Do whatever the body. That is if the condition is true. Go in the body. Then after you have done whatever the body wants to do, now come and increment. Then check the condition again. So it is like increment, check condition, body. Increment, check condition, body. The other side it was that you check a condition, go to body, increment. Are you seeing the difference? That is what they will try to test you.
So the output is different.
It is the same, but the order of performance, the criteria is different. The order of operation is different. However, they all achieve the same thing, but the order of performance is different. So why would someone you choose a while over a for loop? Simplicity. Someone can say, for me, I find a for loop easier. Someone can say, me, I find a while loop easier. But in our exams, they can restrict you. But when you are writing your own program, you can choose if they have not restricted you. Yes. The for loop is done also. The for loop is also done. So, someone will say, okay, when they say a nested for loop, it's just not something different. It means that you'll have a loop within another loop. Meaning that loop will also be executed very many number of times as long as the other outside loop is still working. It just means that you are writing another smaller loop inside another loop. That one is just that. And we shall see as we are doing the past papers, we shall see those cases. So don't worry. As long as you understand the general functionality of the for loop, it's all. Next thing is to go through the what? For loop is done. For each loops. Okay. Let's just move to, what is this for each loops? Let's ignore that for now. This one is used when you want working with the listing. So let's not work on with it. We are not going to look at enumeration and listing in Java. I don't expect the lecturers to reach there. So let's just move to the do while. I want us to look at those basic theory. The do while. Then we look at the two keywords, continue and break. Then we shall call it a night. We shall be done with while loops. We shall be done with loops. So the do while loop works like this. Do something, while check the condition, then you continue. Like you do something first, then you check the condition. That's the while now. While is one that doesn't provide the condition. Then you go. That means at every time, something will always first be done. Then we check the condition. Are we together? Let's understand it together. That they are saying that a do while loop is similar to a while loop. Only that the do while loop is a guaranteed execute at least one time. What do they mean? That it guarantees you that it gives you a guarantee that at least at every one moment something will be done first. Before even looking at the condition. What does that mean? That the moment you come, maybe for example, the moment you come to campus, you pay or you register, you will be guaranteed to get some marks, whether it's 0, but you have to get some marks before even looking at whether you have done the exams or not. But because even for that one who has a missing mark, you will have a 0 there. You understand? That at least something will happen. There is some guarantee. Before even looking at the conditions, we shall have at least one time guarantee of execution of the code we shall have written. Let's understand that. So let's first look at the basic syntax. Let's first understand the basic syntax. That is what is important. Understanding the basic syntax is what is important. Control V. So that's our general syntax. The what they do? So do while. Do while. That means that do something while, then after you have done that something, check the condition, then you go back and do. Meaning always we shall first do something. Then we come and check the condition, then we go back and do. If the condition is true, is false, then we shall not go back. That's what it means. Do, then you open these brackets. Inside here you provide what you want to be done. Then after you provide the while, then you provide inside the condition, which you are calling a Boolean expression. Then until this condition is no longer true, then we shall not go back to do. Hope we are together. So that is all. Let's now go to an example. Let's go to an example. Execution process, that one I have explained. That we first do something every time, then you check the condition next. The flowchart is here also. These flowcharts are easy, by the way, to understand and even remember. That you just follow the criteria. You are just writing down the order of execution. That here we are saying do. You provide the code block. You will provide what you want to be done first. Check the condition. If the condition is true, go back and do it again. Are we together? Until the condition is not true, then you jump out and stop that row. That is all. Let's look at an example. Again, doing the same thing. How are we going to achieve what we have been doing now, this time using the do? While. Same thing. We are doing the same thing, but this time we want to use the do while. I'm removing all this nonsense. This one. Our program is now just syntax, a general syntax of a general program. So, do while. We have said we write it do. What do we want to achieve first? We want to print numbers between 10 and 19. Meaning, we want to start when we want to print from 10. Do print 10 first, then you go on increasing until then you reach it. You understand? Yeah. So do. Sorry. Do print 10. So system. But we have not even written what we want to print. It should be on top here, on top of the do. We want to print int I. Your initial point should be provided on top. Int I equals 10. We want to start from 10. If you want to start from 0, well and good. If they tell you to print only even numbers between 0 and 100, of course you know that I will start from 0. We shall start from 2. Then even numbers, how do we print them? By increasing by 2. Meaning now our I will be I plus 2, not I plus plus. Just modifying your program. They can even tell you to print even numbers, odd numbers, prime. Yes? That one is just a class name. You can name it anything. That's why I've not been modifying it, because it is just anything you choose. It's just a class name. Don't focus on it so much. So system.out dot println, and then we are printing I. Then we close our brackets. While here outside the do, not inside the brackets of do. Don't make that mistake. And while is small w. Inside here we provide our condition. The condition is that 10 should be less, I should be less than or equal to 19. Because the condition will not change right now, because we are still achieving the same thing. If you feel like this operator will confuse you, that means just say less than 20. Are we together? If you feel like less than or equal to will confuse you, will bring equal first, then less next. Just put there less than 19. So of course it will stop on 19. So less than 20, not 19. Then, here we terminate. Don't open while again, because this while is just to provide the condition. Don't open for it again. We terminate it. That is it all. Of course, when we run our program, we shall see what it does. It is bringing 10. Why? We have not provided an increment. We are not increasing our I. How do we do that? You can choose to increase before. Let's do that and we'll see. Or why it is true? Because I don't usually use the do while. It's bringing an error, meaning it is not allowing that. Are we writing it maybe just below here? Oh yeah, because it makes sense. It makes sense that let me show you how do you decide where to put it. We have said do print 10. So to check for the condition, the condition is true, it will go back and print 10. Are you seeing that it's not right? So let's first see when we put I plus plus. Meaning if you want to print, let me run again and we see. Then I will explain after. I want to explain something that is right. Not on estimation. It's not working. I want to explain something that is right. Maybe we put it inside the do. We are trying because we are practicing. That's how now you learn the errors. Yeah. See, it works. Now we can now explain to ourselves. Now here you can explain to yourself by drawing conclusion. And based on what I've learned, this is what is right. But when you are on the paper, you won't have that chance. You just write your answers and you think you are succeeding. Kumbe. You are writing Imarwa. So, let's explain to ourselves that here we are saying, do print 10, please. Then increase that 10, then you check. You see how it makes even sense. There we were trying to print, then we check and increase again. That is not making it the way we wanted it. So it is like, do print 10. Yes, do print that value that we were provided, which is now 10. Increase that 10 by 1, and then check first. Is it still passing our condition? If yes, go back and print. Check it, increase it again. Check, is it still passing our condition? Go back and print like that. Hope that one is clear again. The do while. Yeah, and that is all for today. Unless there is a question. But right now, that's all for today.